Hello, I've had a question in Unit 2, Lesson 5 on Hooke's Law, number 43. So we have a toy gun that has its spring compressed 3 centimeters. So they are giving us delta x, and I'm going to convert that to meters before I make the mistake and carry it through in centimeters. Gives us the mass of the projectile, and again, let's convert that to kilograms. So 0.05 kilograms. Just dividing by 1,000 there. Spring constant, they tell us K. It's 400 newtons per meter of extension. We want to know the velocity of the projectile if it is launched. So, just to give you an idea of what's happened, so inside we have tightly compressed spring, and there's our object. Afterwards, the spring is fully extended, and now the object is moving to the right, so there is no energy left in that spring. So in this case, the elastic energy of the spring was all transferred to kinetic, meaning that our elastic energy will equal the kinetic energy in these two extreme cases, the before. So this is the before, and this is the after. All right, so think of it this way. Elastic energy is the total amount of energy. Your EK at this point is 0. Now all that energy is now kinetic, so that's your total energy. And because the spring has reached its natural rest position, no longer contains any energy, so now it's 0. That allows me to compare or make that work with that formula. 1/2 K delta x squared, 1/2 mv squared. 1/2's going to drop out of both sides. And I just want to know the velocity. So my velocity squared will equal K delta x squared over m. V equals the square root of 400, 0.03 squared over 0.05. Now I just got to crunch that through a calculator. The physics is done at this point. Times 0.03 squared divided by 0.05 equals the root of my answer. So I have it calculated out at 2.68 meters per second. All right, so the velocity of that launch projectile is 2.68 meters per second after the spring has transferred that energy. If you have any questions with that, let me know, and I will do what I can to clarify.